Hello, my name is Roger Noble. I'm pleased to welcome you to this brief introduction on the practicalities of getting started with laser cutting. First, some basics. I'm not an expert, but I do have some experience that I hope might be useful. This is not a presentation that will teach you how to use a particular CAD program. But as a novice, I've faced a few impenetrable but simple steps and also stumbled across a number of best practices that will, I hope, help you through the process, which, like most things, is easy when you know how. The outcome of this process should produce a set of parts akin to a kit from Wills, Metcalfe or similar. All the parts will be flat, but depth and details can be built up by producing layers, often of different thicknesses. In addition, etching details such as brickwork will significantly enhance the design. Parts may need a little cleaning up of any cusp that the laser leaves, and tasks such as mitering corners will need to be done manually if required. A grand title for some simple information. I use TurboCAD 2D on a Mac. I export that design and use my club setup and club laser cutter to produce the final article. This process has highlighted a few compatibility issues along the way, which I will explore later. TurboCAD is a £60 piece of software, so not cheap, but a very professional product with a lot of online support. The club uses an old version of TurboCAD, which was cheap, possibly free in those days, but the current TurboCAD is a much more expensive program. This means I export from TurboCAD, import to TurboCAD, and export from that into the laser cutter software. This extra step of exporting from TurboCAD and importing to TurboCAD is not one that everyone will face. There are many other 2D CAD products available, some of them free, but for me, usability was a key issue, and some of the cheaper alternatives are not as user-friendly, but it's a personal choice. A quick word about materials. I'll look briefly at 4 types. I've used Trolley's, the plastic card. Sometimes this is referred to as Romark, which is an American company and a product not normally available to the UK hobby user. A sheet of Trolley's is around 1100 by 600 millimeters and costs about £30. Beware, products that are significantly cheaper and advertised as suitable for laser cutters aren't, in my experience. This may seem expensive, but with careful use of material, which I'll cover later, it can produce very cost-effective buildings. I personally not used ply, but have used MDF. Most recently, I have used a company called Hobart's, a 450 by 300 millimeter sheet, which is, helpfully, very close to the size of the club laser bed, costs about 80p a sheet for 2mm thickness and £1.40 for 3mm. My thoughts on pros and cons. Many of these are true for any building or other object made from these materials and not specifically to do with laser cutting, but just to cover those particular points. Both the plastic card and the MDF etch very well for such things as mortar courses, not something that can be done effectively with card. The slightly oily finish of Trolley's requires cleaning and possibly a slight sanding to provide a better key for the paint, which is an additional job. MDF is, in my experience, often supplied to a very nominal thickness. What is purportedly 3mm MDF, for instance, might be 3.2, 3.3 or even 3.4mm. Although that doesn't sound much, and in many cases isn't an issue, it is a major problem with any tab and slot joins or external corners. It's imperative you know how thick your final material is, certainly to the nearest 0.1mm, before you start your design. Also worth noting is that MDF and ply can be difficult to cut through for cheaper hobby lasers or in greater thicknesses. I'll discuss how this can be mitigated a little later. You can also cut perspex, although I haven't done so, but again, be careful. Perspex is often cast, poured into a tray as a liquid and allowed to set. It can have a significant, in these terms, difference in thickness across a single sheet. Now I'll look briefly at some lessons I've learnt. Obvious, I'm sure, to anyone with real CAD expertise, but as a novice, not so obvious to me at first. Rules are, of course, meant to be broken, but please consider these as suggestions that might help. All of these are fairly obvious, but nonetheless worth considering for a few moments. It's really important to have a good understanding of what you're trying to get your object to look like before you start. If you're copying a real life item, then its size, shape, etc. will be decided for you. But if not, I found it best to use a real building, even if I removed a few bays of windows, lost a floor, added some doors and so on. Using a real building as a basis meant that architecturally at least it looked right, and knowing what you're trying to do was a big help in the design. Noting the key dimensions became incredibly frustrating and potentially disastrous if you don't do it. You will refer to these often. There are more than those shown here: sizes of windows, sizes of doors, and so on. It also helps if you have a good idea in your head how it will all go together, particularly regards layers and, for instance, how the corners will work. We'll look at how to help with that shortly. Never draw the same thing twice sounds a bit odd, but all CAD programs have some kind, usually several, of replicate functions. On a large building with repetitive features, such as windows, draw it once, then use the replicate function to copy along a floor and between floors. You are much less likely to get errors. Just to show a quick example. I've drawn one window and need to replicate it across all 3 bays and across 2 floors. First, I select the window and use the replicate function to create its companion in the same bay. Obviously, this is what it looks like in TurboCAD. Then I select both windows and select replicate using the major dimensions I noted earlier. And you end up with all the windows drawn. It's quicker and, most importantly, much less likely to produce an error. You can use copy and paste, but risk putting the window in the wrong place. Even a small error will be noticeable on the final building. It is worth spending time to understand how the replicate function works in your software. This is a particularly useful lesson when drawing bricks. Drawing individual bricks will quickly become very tedious. Just one wall of the warehouse I've used to illustrate this has around 17,000 bricks. When starting a new design, the first thing I do is set up the grid. 2 parts, the size and the spacing. TurboCAD draws the grid to a size you can define, even though the drawing area is much bigger. I tend to make the overall size of the grid reflect the size of the laser bed, for reasons I will explain later. The second key dimension is the grid spacing. Typically, a brick measures 9 inches long by 4.5 inches wide by 3 inches high. In 4mm, this equates to 3mm by 1.5 by 1. Thus, for brickwork especially, I use a 0.5mm grid. That said, in a big building, this is a very fine grid and can cause problems by simply selecting the wrong grid point or the snap to grid function, which is generally a good thing, snapping to the wrong point on the grid. When drawing, say, the side of a warehouse, I would change the grid to give a wider spacing to avoid these issues, only tightening up when doing the detail. The other thing to consider is what units you are using for the drawing. I tend to use the model size, so a 100mm long line will produce a 100mm long cut. But particularly if you are drawing a real building and using real dimensions for your source material, it might be better to apply a scale, say 1/76, so a 25-foot long line will still produce a 100mm long cut. It makes no practical difference, and it's just personal preference as to what you find the easiest. Frankly, you can lay out the drawing in the CAD program any way you like, but I have found 2 approaches very worthwhile. The first is to lay out the object, whether it be a building or, say, a wagon or coach, as a net. Simplistically, think of a net as an unstuck cardboard box. On a box, of course, the dotted lines are creases and not cuts. Typically on a building, we might not have a base, and the top, or roof as we would normally call it, is unlikely to be a simple flat face. And so it might look something like this. In a true net, the roof parts will be an angle, in line with the slope of the gable, but I found it easier to draw with all the objects at right angles if possible. The second suggestion is in the use of layers. Now, layers is going to be a very confusing term. There are layers of plastic card or other material to provide the relief on your building, whether they be inset layers to provide windows and doors, or overlay layers to provide architrave, lintels and buttresses, and so on. And the CAD program you are using will have layers. These will be user definable and able to be shown in different colors and are exceedingly important in doing CAD drawings. Unhelpfully, it is a mixture of these last two terms that we will be looking at here. To simplify matters, I hope, I'll refer to the physical layers of plastic card as sheets. They will be datum, an overlay or an inset as appropriate. References to layers will be the layers as used by the CAD program. I will now show briefly how we go about using these layers. The first thing to bear in mind is that there are two types of lines we will draw: cuts and etches. The names are self-explanatory, but there is a twist I will explain later. A cut is intended to separate parts, an etch is intended to provide some surface detail, the most obvious being mortar courses or gaps in planking. So each sheet of material may have, logically, at least two layers, a cut and an etch. In practice, any sheet with brickwork or similar will have two etching layers, as I will explain shortly. Here's what a final wall might look like. We will look at how this is built up in a moment, but I just want to draw your attention to the names of the layers. TurboCAD allows the use of sublayers, which has advantages and disadvantages, so please experiment with how layers work in your software. This is the starting point, the datum layer. All measurements are taken off this layer. This is particularly important at corners, as we shall see. If some of the lines look a little fuzzy, that is the mortar course returns for the brickwork. I'll cover that later. Here the horizontal etch layer has been added. Although this is perhaps the next obvious step, you can see that I would have drawn an overlay layer outline at least earlier, so that I know where the mortar courses finish. Generally, draw the layer outlines, window cutouts, etc. before adding etch detail. And here the vertical etch is added. The value of having two etch layers is twofold. In this instance, it is generally helpful to be able to switch off the horizontal layers when drawing the vertical ones. This is particularly true when trimming lines to the correct length. Secondly, it helps even out the heat of the laser, as we shall see later. Now I've added some detail with a 0.5mm overlay. This includes window surrounds and some brickwork flourishes. Next we see the window frames and window panes. There are two layers. The first one behind the brickwork will be the window frame. The second behind that carries the frame and window pane cutouts. Now I have added all the inset layers, where I have also included some doors. Adding in the overlays at the top and bottom returns us to the final drawing. One final point in drawing layers: beware of copy and paste. Certainly in TurboCAD it does not copy or paste hidden layers. The same applies if you are moving a drawing. Sometimes it's useful to have additional drawings that are not intended to be cut. These may be plans or details that don't show up well on the main drawing. In particular, understanding how the corners will join is a great benefit. Some layers can overlap, some have to be mitered. When you draw this out as full-size plans, it allows you to check the right wall lengths for the various layers. A couple of final points on laying out your drawing. Cuts and etches have width. This will vary from laser to laser and from material to material, but it's in the order of 0.2mm. There are some areas where this is important and some where it can be ignored. And while we're on the subject, lasers do not cut parallel. This is largely because there is more heat at the top, which removes more material. For most thicknesses and materials, this can be ignored, but you should cut a test piece to check both of these factors, particularly if you are planning any tab and slot type joints. I mentioned earlier mortar returns. These are the mortar courses that are on the inside of window and door cutouts. It is possible to replicate these to save an enormous amount of manual work if you want a realistic finish. Here, in this highly magnified view, the blue line is the edge of the brickwork. The orange, green and brown lines are etching lines to represent mortar courses. Small round circles are holes. These are 0.1mm in diameter, with the centre 0.1mm from the edge of the nominal brickwork. As the laser has a 0.2mm width centred on the blue line, it will cut away half the hole, leaving a semicircular slot on the edge of the material, acting as the mortar return. That covers everything I plan to say on laying out the drawing to design a building or other object. In part 2, I'll go on to describe how to get your design ready for cutting and some of the practicalities of using the laser itself.